Close your eyes and breathe deeply. Feel yourself settling into the soft embrace of evening as the first stars begin to appear in the darkening sky. Tonight, we journey together through the greatest story ever told, the birth, life, and destiny of our solar family. Look up at those gentle points of light scattered across the cosmic dark. Each star you see is a sun like ours, perhaps warming planets of its own. But our story begins here, with the star that has watched over Earth for 4.5 billion years. Imagine yourself now, standing in a peaceful meadow as twilight deepens around you, watching the sun slip toward the horizon in its daily journey across the sky. With each breath, feel the gentle pull of forces far greater than yourself, the same gravitational embrace that guides our Earth in its orbital path around the sun, the same cosmic rhythm that has carried our planet through space for over 4 billion years. You are not separate from this celestial dance. You are part of it, connected to every star that twinkles above you, every planet that traces its silent path through the darkness. As the first stars appear in the darkening sky, like gentle lanterns being lit one by one across an infinite garden, you begin to sense the vast yet intimate nature of our solar family. So vast that light from our nearest stellar neighbor takes over 4 years to reach us, yet so intimate that the same sunlight warming your face has traveled just 8 minutes from our star's surface. Breathe slowly now, and feel how the rhythm of your breath connects you to the cosmic breathing of our solar system. Planets inhaling cosmic energy, exhaling their own gentle heat into the space between worlds. Our ancient ancestors understood this connection in their bones, even without telescopes or spacecraft, to reveal the hidden choreography of the heavens. The Babylonian star watchers of 4,000 years ago stood beneath these same constellations, tracking the wandering planets with patient devotion, their clay tablets recording the movements of Venus and Mars like love letters written to the sky. Egyptian temple astronomers stretched their shadows across pyramid steps, aligning their monuments to catch the first rays of sunrise on sacred days, while Mayan calendar keepers drifted across jungle clearings, guided by Venus's patient dance through the cycles of seasons and years. As you breathe deeper into relaxation, let your awareness expand beyond Earth's protective atmosphere, beyond the gentle curve of our blue-white world, to encompass the full family of planets that share our sun's gravitational embrace. Picture them now as glowing islands floating on the velvet darkness of space, Mercury, swift and small, completing its tight orbit in just 88 Earth days, forever racing around our star like an eager child circling a campfire. Venus follows, wrapped in pearl-white veils of cloud that catch and scatter sunlight, making it the brightest wanderer in our sky after the sun and moon. Ancient peoples called it both morning and evening star, not knowing they watched the same world reveal itself in different parts of its orbital journey. Breathe gently with Venus now, as it slowly rotates backwards through its long day, where sunrise comes from the west, and a single day lasts longer than a full year on Earth. Beyond Venus lies our own Earth, blue marble swirled with white clouds, the only world we know where liquid water flows freely across the surface, where continents drift like slow thoughts across the face of a dreaming planet. Our moon keeps faithful attendance, locked in gravitational partnership, its gentle pull creating the rhythm of tides that has shaped life's evolution for billions of years. Feel that lunar influence now, in the subtle rhythm of your heartbeat, in the ebb and flow of your breathing, connected to the same forces that move entire oceans. Mars glows like a gentle ember in the distance, red with iron oxide dust that covers its ancient surface, dust that tells the story of a world that once ran with rivers and may have harbored its own forms of life. The red planet rotates with a rhythm almost identical to Earth's, its day lasting just 37 minutes longer than ours, its seasons stretching twice as long because its year encompasses nearly 2 Earth years in duration. Let your awareness drift further outward, now, floating gently through the asteroid belt, where countless rocky fragments dance in loose formation between Mars and Jupiter, not a chaotic debris field as often imagined, but a graceful scattered community of worldlets, each following its own perfectly calculated orbital path, some no larger than city blocks, others approaching the size of small moons. Jupiter rises like a protective giant beyond the asteroids, its massive gravitational embrace gathering more than twice the mass of all other planets combined. Breathe deeply and feel Jupiter's protective influence, how its enormous gravity has spent billions of years deflecting comets and asteroids that might otherwise rain down upon the inner worlds, acting as a cosmic guardian for smaller planets like our Earth. Jupiter's 4 largest moons, Io, Europa, Ganymede, and Callisto, orbit like planets in miniature, each world unique, each carrying its own mysteries beneath surfaces of rock and ice. Saturn drifts beyond Jupiter like a cosmic jewel, its ring system catching and scattering sunlight in displays of impossible beauty. The rings are not solid but composed of countless ice particles, each piece following its own orbital dance, shepherded by tiny moons that move among the ring material, like graceful gardeners tending infinite flower beds of frozen water. Imagine yourself floating peacefully above Saturn's rings, watching the play of light and shadow across bands of ice that stretch for hundreds of thousands of kilometers. The ice giants Uranus and Neptune spin in distant harmony, their blue-green atmospheres colored by methane that absorbs red light and reflects the shorter blue wavelengths back into space. Uranus rolls on its side as it orbits, perhaps knocked into this unusual orientation by some gentle cosmic encounter billions of years ago, creating seasons that last decades as different hemispheres point toward or away from the distant sun. Neptune, the windiest world in our solar system, wraps itself in storms that race around the planet at speeds that would dwarf any earthly hurricane, yet from our perspective appears as a serene blue dot, peaceful and constant in its 165-year orbital journey. As your breathing becomes deeper and more relaxed, expand your awareness to include the countless smaller members of our solar family, dwarf planets like Pluto, still orbiting faithfully in the cold outer reaches, its heart-shaped plains of nitrogen ice. Speaking of geological processes that continue even in the deep freeze of the Kuiper Belt, comets drift in the even more distant Oort cloud, like sleeping messengers waiting to begin their long journeys toward the inner solar system, carrying pristine samples of the original materials from which our entire cosmic family formed. All these worlds, from tiny Mercury to distant Neptune, from rocky asteroids to icy comets, move together through space like dancers who have learned their steps across billions of years of practice. Feel yourself joining this eternal dance now, your body relaxing into the gravitational rhythms that connect all matter in our solar system, the same forces that keep planets in their paths, that create the gentle tug of tides, that hold our feet planted on Earth's surface. Embrace you now in invisible threads of connection to every other piece of matter in our cosmic neighborhood. The solar wind, a gentle stream of particles flowing outward from our sun's surface, creates a vast bubble around our entire planetary family, the heliosphere, protecting us from the harsher radiations of interstellar space. Breathe softly now, and imagine this solar embrace surrounding you like the warmest, most protective blanket, a sphere of influence that extends far beyond Pluto's orbit, where the solar wind finally meets and mingles with the thin materials of interstellar space. Ancient light carries these images to your eyes. Photons that left the sun's surface 8 minutes ago, photons that departed Jupiter nearly an hour past, light that began its journey from distant Neptune over 4 hours before this moment. Yet somehow, in the gentle magic of consciousness and imagination, you can encompass all these distances in a single breath, holding the entire solar system in your awareness like a carefully constructed model, beautiful and complete. Let yourself settle deeper now into this cosmic perspective, feeling how your individual existence is both infinitely small in the context of planetary distances and times, and infinitely significant as a conscious being capable of contemplating these vast scales with wonder and understanding. You are made of elements forged in the hearts of stars that lived and died billions of years before our sun was born, star stuff organized into the magnificent complexity of living, thinking matter. As you prepare to journey deeper into the story of how our solar system came to be, feel gratitude flowing through you like a gentle tide, gratitude for the billions of years of cosmic evolution that led to this moment, for the delicate balance of forces that allows liquid water to exist on Earth's surface, for the protective atmosphere that shields us from harmful radiation while allowing life-giving sunlight to warm our world. The same carbon atoms in your body have cycled through countless other forms, perhaps once part of ancient forests, perhaps dissolved in prehistoric oceans, perhaps locked in limestone created by long-extinct sea creatures. The calcium in your bones may have formed in the heart of a massive star that exploded before our solar system existed, scattering heavy elements across space to be gathered eventually into the planetary materials from which Earth formed. You are not separate from the cosmos. You are the cosmos becoming aware of itself, stellar matter awakened to consciousness, capable of feeling wonder at the very processes that created you. And as you breathe beneath this celestial canopy, feeling the gentle pull of gravity connecting you to distant worlds, sensing the solar wind that protects and embraces our entire planetary family, preparing to drift deeper into the ancient story of how these cosmic relationships began, remember that every breath connects you to the same atmosphere that has nurtured life on Earth for billions of years. With each inhalation, you draw in oxygen, exhaled by countless plants across the ages. With each exhalation, you add your own breath to the global circulation that connects all living things on our blue-green world. So rest now in this knowledge of connection, this understanding that you belong to something vast and ancient and beautiful, that your consciousness is a temporary flowering of the same matter and energy that formed planets and stars and galaxies. Let this cosmic perspective settle around you like the softest blanket, preparing your mind for the gentle journey ahead through deep time, back beyond memory, beyond human story, to the dawn before our sun first smiled into the darkness. Drift gently now through the river of time, flowing backward like a dreamer, descending through layers of memory, beyond the rise and fall of civilizations, beyond the first stirrings of life on Earth, beyond the formation of our planet itself, to a time when our region of space held nothing but the softest whisper of cosmic materials scattered like seeds across the infinite garden of the galaxy. Breathe slowly and deeply now, allowing each exhale to carry you further into the gentle past. 4.5 billion years ago, when what would become our solar system existed only as potential, as a promise written in the delicate distribution of gas and dust between the stars. Imagine yourself floating weightlessly in this primordial peace, suspended in a vast molecular cloud that stretches across many light-years of space, so thin that the best vacuum chambers on Earth would seem dense by comparison, yet containing within its gossamer embrace all the materials that would eventually organize themselves into planets and moons, asteroids and comets, and the brilliant star that would warm and illuminate them all. Feel the absolute stillness around you, the profound quiet of space before gravity began its patient work of gathering, when particles of dust and molecules of gas drifted in gentle currents so slow that billions of years would pass between the smallest changes. This stellar nursery was not empty darkness, but filled with the softest possible light, starlight from distant suns, scattered and rescattered by countless tiny particles, until it became a barely perceptible aurora, like moonlight filtered through the thinnest of veils. The temperature hovered just a few degrees above absolute zero, cold beyond earthly experience, yet not the harsh cold of absence, but the gentle cold of infinite patience, of matter waiting quietly for the moment when gravity would whisper its first invitation to dance. As you float in this primordial quietude, breathing gently with the rhythm of cosmic time, begin to sense the invisible architecture of forces that permeate even the emptiest seeming regions of space. Gravity, though so weak that it can barely influence individual particles, maintains its patient presence everywhere, creating the faintest possible gradients in the fabric of space-time, subtle variations in density that would eventually grow into the massive structures we call solar systems and galaxies. The materials surrounding you in this ancient time carry the memories of previous generations of stars, heavy elements forged in stellar furnaces and scattered across space by the gentle exhalations of dying suns. Iron atoms that would someday flow in the blood of living creatures, silicon that would form the rocky hearts of terrestrial planets, oxygen that would combine with hydrogen to create the water molecules essential for life. All these cosmic gifts drift peacefully in the molecular cloud, waiting for their next chapter in the eternal story of matter and energy. Carbon atoms, those versatile builders of complex molecules, float alongside nitrogen and sulfur, phosphorus and calcium, all the elements heavier than hydrogen, and helium existing as tiny minorities in a cosmos still dominated by the simplest atomic structures. Breathe slowly now, and contemplate how these scattered elements, drifting in isolation across light-years of space, carry within themselves the potential for consciousness, for the very awareness that allows you to imagine this ancient scene. Something gentle begins to stir in this cosmic tranquility. Perhaps the shockwave from a distant supernova, traveling at thousands of kilometers per second, yet taking millions of years to cross the galaxy, arriving as the softest possible disturbance in the equilibrium of the molecular cloud. Or perhaps the gravitational influence of a nearby star, its own formation sending ripples through the fabric of space that reach across light years to caress the edges of our primordial nebula with invisible fingers of tidal force. Feel this first gentle stirring as you breathe in, a slow inhalation that draws scattered materials together with the patience of geological time. The process begins not as a violent collapse but as the most gradual of embraces, gravity working so slowly that individual particles might drift for thousands of years before their paths curve enough to bring them closer to their neighbors. Density increases like dew gathering on morning grass, imperceptibly at first, then with growing momentum as more material arrives to strengthen the gravitational pull. The solar nebula begins to take shape around you like a vast, slow-motion whirlpool, particles of dust and gas following spiral paths that gradually flatten into a disk. Imagine yourself at the center of this gentle maelstrom, watching matter flow inward like the slowest of rivers converging toward a distant sea. The process occurs over millions of years, each particle following its own unique trajectory through space and time, yet somehow all coordinating in the gravitational choreography that will eventually birth our solar system. Temperature gradients establish themselves with the delicacy of watercolors blending on wet paper, closer to the growing concentration of mass at the center, where our sun will eventually ignite. Materials warm slightly from the gravitational energy released by infalling matter. Further from this protostellar core, in the regions where gas giants will form, temperatures remain cold enough for water ice to condense from vapor, creating tiny snowflakes that drift through the void, like frozen memories of Earth's future oceans. Breathe deeply now, and feel yourself becoming part of this primordial dance, your consciousness flowing with the currents of gas and dust, experiencing the birth of order from apparent chaos, the emergence of structure from the patient working of natural forces. The frost line marks not a sharp boundary but a gradual transition, where the warmth of the growing proto-sun fades into the eternal cold of outer space, creating different environments where different types of planets will eventually form. Rocky materials, silicates and metals that can withstand higher temperatures, concentrate in the inner regions of the forming solar system, while volatile materials like water, methane and ammonia remain stable only in the cooler outer reaches. Yet even this separation occurs with infinite gentleness, like cream settling in milk left undisturbed, creating layers and gradients that will determine the character of worlds yet to be born. The proto-sun grows at the center of this cosmic nursery, not yet shining with nuclear fire, but glowing dimly with the heat of gravitational contraction. Picture this embryonic star as a warm ember in the cosmic darkness, pulsating gently with gravitational rhythms as it slowly gathers mass from the surrounding nebula. Its magnetic field begins to organize, creating the first stirrings of the solar wind that will eventually carve out the heliosphere and define the boundaries of our solar system's influence. Turbulence develops in the nebula disk, but not the chaotic turbulence of terrestrial storms. Rather, a cosmic turbulence that operates on scales of astronomical units and timescales of thousands of years, creating eddies and currents in the flow of materials that will eventually become the seeds around which planets form. Feel yourself flowing with these vast currents, breathing with the rhythm of matter, organizing itself across regions larger than the orbit of Neptune. Magnetic fields thread through the nebula material like invisible rivers, channeling the flow of charged particles, and creating the first hints of the complex electromagnetic environment that will characterize the mature solar system. These fields couple the rotation of the growing proto-sun to the orbital motion of the surrounding disk, transferring angular momentum outward and allowing the central mass to contract while the disk spreads and flattens. As you continue breathing slowly and deeply, letting each breath carry you further into this ancient time, begin to sense how the apparently random motions of countless particles gradually resolve into the ordered dance of orbital mechanics. Conservation of energy and angular momentum work their patient magic, transforming the three-dimensional chaos of the initial molecular cloud into the flat, rotating disk from which planets will emerge. Dust grains begin their own slow journey toward planethood, first as individual microscopic particles, then gradually sticking together when gentle collisions bring them into contact. Static electricity and van der Waals forces provide the delicate attractions that allow the first aggregations to form, fluffy assemblages of dust and ice that grow from microscopic to pebble-sized over thousands of years of patient accumulation. The process resembles snowflakes growing in a slow-motion blizzard that lasts for millions of years, each particle following its own orbital path around the proto-sun, while occasionally encountering others in gentle embraces that add mass and complexity to the growing collection of solid bodies. Imagine yourself drifting alongside these primordial snowballs, feeling their gentle gravitational tugs as they slowly accumulate the materials that will eventually become the rocky cores of planets. Time flows like honey in this early epoch, each million years bringing subtle changes that would be imperceptible to any hypothetical observer, but that collectively transform the entire character of our forming solar system. The proto-sun continues its slow gravitational breathing, contracting and warming as it approaches the threshold of nuclear fusion, while the surrounding disk evolves from smooth distributions of gas and dust to increasingly complex structures of rings and gaps, concentrations and rarefactions. Feel the profound patience of these cosmic processes, as you breathe in unison with the nebula flows, understanding that the apparent slowness masks incredible precision, every particle following exact mathematical trajectories, determined by the interplay of gravity, electromagnetic forces, and the conservation laws that govern all motion in the universe. What appears as chaos contains within itself the seeds of the most exquisite order, the future orbital harmonies of planets and moons dancing in gravitational resonance. The chemical diversity of the nebula reflects the entire history of stellar evolution in our galactic neighborhood. Helium forged in the first few minutes after the Big Bang, carbon and oxygen created in the hearts of medium-mass stars, iron and nickel synthesized in the final moments of massive stellar lives, gold and platinum scattered by the collisions of neutron stars. Contemplate now how these elements, born in cosmic furnaces across billions of years of galactic history, have gathered here in this quiet molecular cloud, preparing to be organized into a new chapter of the cosmic story. Isotopic ratios preserve the signatures of these ancient stellar processes like fingerprints in the cosmic dust, allowing future generations of scientists to read the history of stellar nucleosynthesis in the materials of meteorites and planetary surfaces. Each grain of dust carries within itself a library of information about the stars that died to make our solar system possible, a genealogy of stellar evolution written in the language of nuclear physics. As this section of our cosmic lullaby draws toward its gentle close, breathe deeply and feel yourself preparing for the next phase of the journey, when the patient processes of accretion will begin to organize these scattered materials into the first solid bodies of our solar system. The stage is set, the materials gathered, the fundamental forces aligned for the magnificent act of planetary formation that will unfold over the next several million years. Rest now in this primordial peace, floating in the soft aurora light of the proto-solar nebula, surrounded by the building blocks of worlds, feeling the gentle stirrings of gravity as it begins its patient work of creating order from apparent randomness. Let your breathing synchronize with the slow pulse of cosmic time, each inhalation drawing you deeper into the ancient story, each exhalation releasing you into the flow of materials that will soon begin gathering into the familiar worlds of our solar family. The darkness around you is not empty, but pregnant with potential, every particle of dust and molecule of gas carrying within itself the promise of future complexity, future planets, where weather systems will develop, where geological processes will sculpt landscapes, where the chemistry of life may emerge from the patient organization of matter and energy. Breathe softly now, and prepare to witness the first stirrings of this cosmic creativity, as gravity begins to gather these scattered seeds into the embryonic worlds that will become our solar companions. Drift now through the flowing river of deep time, carried gently forward from the primordial quiet of the solar nebula, to witness the most momentous awakening in our cosmic family's history, the moment when our sun first opened its eyes and began to shine with the steady light that would sustain worlds for billions of years to come. Breathe slowly and deeply now, feeling yourself floating at a comfortable distance from the protostellar core, as it approaches the magical threshold where nuclear fusion begins, where hydrogen atoms, compressed and heated by the patient force of gravity, finally surrender to the embrace that transforms them into helium and releases the gentle energy that powers all life on Earth. The ignition of nuclear fusion does not occur as a sudden explosion, but rather as a gradual awakening, like dawn light slowly brightening the horizon of space. Imagine yourself witnessing this cosmic sunrise as you breathe gently in rhythm with the proto-sun's first tentative pulses, feeling the warmth begin to radiate outward as hydrogen atoms in the stellar core reach temperatures of millions of degrees, moving so rapidly that they overcome their natural electrical repulsion and fuse together in the nuclear reaction that will continue for the next 10 billion years. At first, the newborn star flickers uncertainly, like a candle flame learning to burn steadily in the cosmic wind. The balance between gravitational collapse and radiation pressure requires delicate adjustment, the star's core temperature and density finding the perfect equilibrium that will allow it to shine with remarkable stability for eons beyond any earthly measure of time. Feel this stellar heartbeat synchronizing with your own breathing, each nuclear pulse in the sun's core corresponding to millions of hydrogen atoms joining together in the cosmic alchemy that creates light and warmth. As our sun establishes its steady nuclear burning, the character of the entire solar nebula begins to transform around it. The stellar wind, a gentle stream of charged particles flowing outward from the sun's surface, sweeps through the disk of surrounding materials like a cosmic breeze, carrying away the lighter gases from the inner regions while allowing heavier materials to remain and begin their own patient process of accumulation into solid worlds. Breathe softly now, and feel yourself drifting closer to the inner solar system, where the first terrestrial planets begin their gradual assembly from countless smaller bodies called planetesimals, rocky and metallic chunks, ranging in size from pebbles to mountains, each following its own orbital path around the young sun, while occasionally encountering others in the gentle collisions that gradually build larger and larger accumulations of solid matter. Mercury forms closest to the sun, where only the most heat-resistant materials can remain solid in the intense stellar radiation. This smallest of planets emerges as a concentrated ball of iron and rock, its metallic core making up nearly 3/4 of its radius, suggesting that much of its original rocky mantle may have been stripped away by the solar wind or vaporized by impacts during the chaotic early period of planetary formation. Picture Mercury now as a dense, slowly rotating ember in the sun's warm light, completing its swift 88-day orbit, like a faithful companion staying close to its stellar parent. Venus accumulates at a more comfortable distance, where silicate rocks and metals can condense and accrete into a world nearly identical to Earth in size and mass. Yet subtle differences in distance from the Sun will eventually create dramatically different evolutionary paths for these sister planets. Imagine Venus in its youth, glowing softly with the heat of formation, its surface still molten from the energy of countless impacts as planetesimals continue to rain down from the surrounding disk of debris. The thick atmosphere that will eventually create Venus's extreme greenhouse effect begins to accumulate from volcanic outgassing and the vaporization of volatile rich impactors. Our own Earth forms in what astronomers call the habitable zone, that region around a star where liquid water can remain stable on a planet's surface, neither freezing solid nor boiling away into space. Feel yourself gently descending toward the forming Earth, watching as countless impacts gradually build our world from cosmic debris, each collision adding mass and heat to the growing planet. The early Earth exists in a state of constant transformation, its surface repeatedly melted and reformed by the energy of impact events, yet slowly cooling as the rate of bombardment decreases and heat can begin to radiate away into space. The formation of our moon occurs during this dynamic period, likely the result of a Mars-sized object called Theia encountering Earth in what was not a catastrophic collision, but rather a cosmic dance that resulted in the merger of two developing worlds. Breathe gently as you witness this ancient ballet, watching as materials from both bodies are scattered into orbit around Earth, where they gradually coalesce into the companion that will stabilize our planet's rotation and create the tidal rhythms that will nurture life for billions of years. Mars assembles further from the Sun, where water ice can remain stable and contribute to planetary formation. The red planet grows to about half Earth's diameter before the depletion of nearby materials and gravitational perturbations from the forming gas giants halt its further growth. Picture young Mars as a world of promise, with a thicker atmosphere and warmer surface temperatures that allow liquid water to flow in rivers and pool in lakes, carving the valley networks and erosional features that we can still observe today beneath the planet's current desert surface. The asteroid belt between Mars and Jupiter represents a region where planetary formation was interrupted by the gravitational influence of nearby Jupiter. Rather than a single large world, this region becomes populated by countless smaller bodies, from tiny pebbles to objects hundreds of kilometers in diameter, each following its own stable orbit around the Sun. Imagine yourself floating among these primordial worldlets, feeling their gentle gravitational tugs as they perform their ancient dance, some occasionally perturbed into new orbits that will eventually bring them into contact with the inner planets as meteorites carrying samples of the early solar system. As you breathe in rhythm with these planetary formation processes, expanding and contracting like the young worlds themselves as they accumulate mass and settle into stable orbits, begin to sense how each terrestrial planet develops its own unique character based on subtle differences in formation conditions. Distance from the Sun determines which materials can condense and remain solid, while the availability of planetesimals in each orbital region influences how large each world can grow. Early atmospheres begin to form around the terrestrial planets, through a combination of volcanic outgassing and volatile delivery by impacting comets and asteroids. These primordial atmospheres differ dramatically from the ones we observe today, often containing massive amounts of water vapor, carbon dioxide, and other gases released from the planetary interiors as they cool and differentiate into core, mantle, and crust. Earth's early atmosphere creates a thick blanket that traps heat from both solar radiation and the continued bombardment of cosmic debris, Feel the gentle greenhouse effect warming the young Earth as you breathe slowly with the rhythm of atmospheric circulation, watching as water vapor condenses and begins to fall as the first rains in Earth's history, creating the oceans that will become life's cradle. These primordial seas are not the clear blue waters of modern Earth, but rich broths of dissolved minerals and organic compounds, chemical laboratories where the first experiments in biology will soon begin. The process of planetary differentiation unfolds over millions of years, as the heat generated by impact energy and radioactive decay melts the planetary interiors, allowing denser materials like iron and nickel to sink toward the centers of worlds, while lighter silicate materials rise to form rocky mantles and crusts. Imagine this internal organization occurring like layers of cream settling in milk, but over vast scales of pressure and temperature that transform solid rock into flowing, convecting currents of molten material. Earth's iron core begins to solidify and generate the magnetic field that will protect our planet's atmosphere from being stripped away by the solar wind, creating the invisible shield that allows Earth to retain its water and develop complex atmospheric chemistry. Breathe gently now and feel this magnetic embrace surrounding you like the most protective blanket, deflecting harmful charged particles and creating the auroral displays that paint the polar skies with rivers of light. Volcanic activity shapes the surfaces of all the terrestrial worlds during this formative period, not as destructive explosions but as the patient exhalation of planetary interiors, releasing gases and molten rock that will eventually cool to form the first solid surfaces. On Earth, volcanic outgassing contributes water vapor, carbon dioxide and nitrogen to the atmosphere, while creating the first continental landmasses that rise above the primordial oceans. As this chapter in our solar system's formation draws toward its gentle close, breathe deeply and feel yourself surrounded by the four inner worlds in their youthful forms. Mercury, dense and metallic, racing around the Sun in its tight orbit. Venus, shrouded in thick clouds, but still cooling toward the surface conditions that might once have supported oceans. Earth, blue-green, with newly formed seas and a protective magnetic field. Mars, red with iron-rich soils, but still warm enough for liquid water to flow across its surface. The Sun shines steadily at the center of this inner system, its nuclear fusion now established in the stable pattern that will continue for billions of years, providing the energy that drives atmospheric circulation, powers the water cycle, and will eventually enable the chemistry of life to emerge from non-living matter. Feel this solar warmth on your face now as you float peacefully above the young Earth, sensing how the same nuclear fires that heat and illuminate our world today began their steady burning in this ancient epoch. Yet beyond these inner worlds of rock and metal, the outer reaches of the solar system hold their own wonders waiting to be born. The gas giants that will dominate the outer solar system with their massive gravitational influences, shepherding smaller bodies into stable orbits and protecting the inner worlds from excessive bombardment by comets and asteroids. Prepare now to drift outward through the asteroid belt, breathing gently with the rhythm of orbital motion, ready to witness the formation of Jupiter, Saturn, and their distant cousins in the cold outer reaches, where ice and gas combine to create worlds unlike anything in the inner solar system. The terrestrial planets now established in their orbits represent just the beginning of our solar system's story, the inner foundation upon which the rest of the cosmic architecture will be built. Rest for a moment in contemplation of these young worlds, feeling your breathing synchronize with their orbital periods as they begin the ancient dance that will carry them through billions of years of continued evolution, climate changes, and for at least one of them, the emergence of life itself. Drift gently now beyond the realm of rock and metal, carried by the slow currents of cosmic time toward the outer reaches of our forming solar system, where the dance of planetary formation takes on an entirely different character in the cold regions beyond Mars. Breathe slowly and deeply as you float through the asteroid belt, feeling the gentle gravitational tugs of countless rocky fragments, each one a reminder of the planet that might have formed here, if not for Jupiter's overwhelming influence. Here in the transition zone between the inner terrestrial worlds and the outer giants, we begin to glimpse the magnificent diversity that makes our solar system a cosmic symphony of different planetary voices. Beyond the asteroid belt, where the sun's warmth fades to a gentle whisper and ice can remain stable for billions of years, the process of planetary formation follows different rules entirely. Picture yourself suspended in this realm of perpetual twilight, where water vapor condenses into tiny crystals that drift like cosmic snowflakes through the solar nebula. The frost line marks not just a change in temperature, but a transformation in the very materials available for planet building. Hydrogen compounds like water, ammonia, and methane can freeze solid, dramatically increasing the amount of material available for accumulation into planetary cores. Jupiter begins its formation as these icy materials collect into larger and larger aggregations, rocky and metallic cores growing massive enough to gravitationally capture the hydrogen and helium gas that still surrounds the young sun. Breathe gently with Jupiter's gathering process, feeling how each breath draws in more cosmic material. Each exhalation represents the settling of matter into the gravitational embrace of what will become the largest planet in our solar family. The process resembles a cosmic snowball rolling downhill, growing larger and more massive as it encounters additional materials, until it reaches the critical threshold where its gravity becomes strong enough to hold onto gaseous atmosphere permanently. The young Jupiter grows with remarkable speed. Once this threshold is crossed, sweeping up hydrogen and helium from its orbital neighborhood, like a cosmic vacuum cleaner, operating in slow motion over thousands of years. Imagine yourself watching this majestic process from a safe distance, seeing how Jupiter's atmospheric bands begin to organize themselves into the beautiful striped patterns we recognize today, different colored zones representing different chemical compositions and wind speeds in the planet's rapidly rotating atmosphere. As Jupiter reaches nearly its full size, its powerful gravity begins to influence the formation of other worlds throughout the solar system. Orbital resonances develop like musical harmonies, with smaller bodies finding stable niches where their orbital periods relate to Jupiter's in simple mathematical ratios. 2 orbits for every one of Jupiter's, 3:1, 5:2, creating a celestial mechanics that resembles the harmonic relationships in a vast cosmic chord. Feel yourself flowing with these gravitational harmonies as you breathe slowly and steadily, understanding how Jupiter's influence extends far beyond its immediate neighborhood to shape the character of the entire solar system. Its massive gravity acts like a protective shepherd, deflecting potentially dangerous comets and asteroids away from the inner planets, while simultaneously organizing the remaining debris into stable populations that will persist for billions of years. Saturn forms in the next outward orbital position, following a similar pattern of ice and rock accumulation, followed by atmospheric capture, but growing somewhat smaller than Jupiter due to the decreasing density of materials at greater distances from the Sun. Picture Saturn as Jupiter's smaller sibling, spinning rapidly through its formation process and developing the oblate shape that makes it the least dense of all planets, so low in density that it would actually float if placed in an ocean large enough to hold it. The formation of Saturn's magnificent ring system may have begun during this early period, either through the disruption of a large moon that wandered too close to the planet's gravitational influence, or through the capture and grinding of countless smaller icy bodies into the billions of individual particles that today create the most spectacular planetary feature in our solar system. Breathe gently now and imagine yourself floating above Saturn's forming rings, watching ice particles organize themselves into the intricate pattern of gaps and divisions, shepherded by tiny moons that act like cosmic traffic directors guiding ring material into stable orbits. The relationship between Saturn and Jupiter creates additional layers of gravitational harmony throughout the outer solar system, their combined influence establishing regions of stability and instability that determine where smaller bodies can survive and where they will be ejected or captured. This dynamic reshaping of the solar system's architecture occurs over millions of years, like dancers learning their steps in a cosmic ballet that will continue for billions of years. As you drift further outward through the gentle currents of the forming solar system, breathing slowly with the rhythm of orbital mechanics, the ice giants Uranus and Neptune begin their own unique formation stories in the cold outer reaches, where even hydrogen and helium become more difficult to capture and retain. These worlds may have formed closer to the Sun, and later migrated outward through gravitational interactions with Jupiter and Saturn, or they may have assembled in their current positions from the gradually decreasing supply of raw materials. Uranus develops its unusual tilted orientation during this formative period, perhaps through a gentle collision with another planetary embryo that knocked the world onto its side, creating the unique situation where the planet's poles point alternately toward and away from the Sun during its 84-year orbital period. Picture this tilted world spinning like a slowly rotating barrel as it orbits the distant Sun, its unusual orientation creating seasons that last decades and atmospheric dynamics unlike anywhere else in the solar system. Neptune settles into the outermost position among the major planets, its deep blue atmosphere colored by methane that absorbs red light and reflects the shorter blue wavelengths back into space. Despite its great distance from the Sun, Neptune radiates more heat than it receives from solar radiation, suggesting that it continues to contract slowly and release gravitational energy left over from its formation process billions of years ago. Breathe deeply now as you contemplate these ice giant worlds, feeling how their formation represents the outer limit of significant planetary mass accumulation in our solar system. Beyond Neptune, the available materials become so sparse and the orbital periods so long that only smaller bodies like dwarf planets and comets can form, creating the scattered populations of icy objects that mark the gradual transition from our sun's gravitational dominance to the influence of nearby stars. The moons of the gas giants form through processes that mirror planetary formation on smaller scales, each major moon system representing a miniature version of the original solar nebula. Jupiter's four largest moons, Io, Europa, Ganymede, and Callisto, organize themselves into a chain of orbital resonances, with Io completing 4 orbits for every 2 of Europa and every 1 of Ganymede, creating a gravitational symphony that pumps tidal energy into these worlds and maintains geological activity for billions of years. Imagine yourself floating among Jupiter's moons, feeling their gentle gravitational interactions as they perform their ancient dance of resonance and tidal heating. Io's volcanic activity, Europa's subsurface ocean, Ganymede's magnetic field, and Callisto's ancient cratered surface all result from the delicate balance of forces established during this formative period, when the moons first settled into their current orbital relationships. Saturn's moon system develops its own unique architecture, with tiny shepherd moons guiding the ring particles into stable configurations, while larger moons like Titan accumulate thick atmospheres of nitrogen and organic compounds. Picture Titan as a world wrapped in orange haze, its surface hidden beneath clouds that rain liquid methane into hydrocarbon lakes, creating a landscape that resembles Earth's water cycle, but operating with entirely different chemistry. The process of late heavy bombardment affects all the newly formed worlds during this period, as gravitational perturbations from the migrating gas giants scatter remaining debris throughout the solar system. Rather than a catastrophic rain of destruction, this represents the final stage of planetary formation, delivering water and organic compounds to the inner planets, while gradually clearing the solar system of the smaller debris that filled interplanetary space during the earlier phases of accretion. Breathe slowly and feel yourself witnessing this cosmic housekeeping, watching as comets from the outer solar system spiral inward to deliver their precious cargo of volatiles to worlds that formed too close to the sun to retain these materials during their initial assembly. Each impact adds to the growing inventories of water, carbon compounds, and other materials essential for the later development of complex chemistry and possibly life itself. The Kuiper Belt begins to organize itself during this period as a reservoir of icy bodies beyond Neptune's orbit, objects too small to be considered planets but too numerous to ignore, including dwarf planets like Pluto, that preserve samples of the original materials from which the outer solar system formed. Imagine these distant worlds as cosmic time capsules, drifting in the cold outer darkness, yet maintaining their own gravitational relationships and orbital dynamics. Some paired in binary systems like cosmic dancers frozen in eternal partnership. Even more distant, the Oort cloud begins to take shape as a vast spherical shell of cometary nuclei, perhaps containing trillions of individual objects in slow, highly elliptical orbits that extend halfway to the nearest star. These objects represent the outermost members of our solar family, so distant that they take millions of years to complete single orbits around the Sun, yet gravitationally bound and occasionally perturbed into the inner solar system, where they become the spectacular comets that have inspired human imagination for millennia. As this section of our cosmic journey draws toward its gentle close, breathe deeply and feel yourself encompassing the full architecture of our solar system in its mature form. The terrestrial planets with their rocky surfaces and thin atmospheres, the gas giants with their massive sizes and complex moon systems, the asteroid belt and Kuiper belt populations of smaller bodies, and the distant Oort cloud marking the edge of our Sun's gravitational influence. Each component of this cosmic family has found its proper place through the patient working of gravitational forces, orbital mechanics, and the conservation laws that govern all motion in the universe. Feel the harmony of these relationships now as you breathe gently with the rhythm of planetary orbits, understanding how each world's formation and evolution contributes to the stability and beauty of the whole system. The young solar system has transformed from a chaotic disk of gas and dust into an ordered family of worlds, each unique yet all connected through the invisible threads of gravity that will maintain their relationships for billions of years to come. Prepare now to witness how these worlds mature and develop their individual characteristics, breathing slowly as you drift forward through cosmic time toward the Golden Age, when our solar system reaches its full potential for diversity, beauty, and perhaps the greatest wonder of all, the emergence of life itself on at least one of these remarkable worlds. Drift gently forward now through the flowing river of cosmic time, carried by currents of starlight and solar wind, toward the magnificent epoch, when our solar family reaches its full maturity and begins to express the incredible diversity that makes each world a unique experiment in planetary evolution. Breathe slowly and deeply as you float through this golden age of our solar system, feeling the warmth of our sun as it settles into its long period of stable nuclear burning, the gentle rhythm of planetary orbits that will continue unchanged for billions of years. This is the time when worlds become truly themselves, when the raw materials and gravitational architecture established during formation begin to flower into the complex, beautiful, and sometimes surprising characteristics we observe today. The sun shines with steady brilliance at the heart of our cosmic garden, its nuclear fusion now perfectly balanced between the inward pull of gravity and the outward pressure of radiation, creating the stable energy source that will power planetary atmospheres, weather systems, geological processes, and eventually, the chemistry of life itself. Feel this solar heartbeat as you breathe, each pulse of nuclear energy in the sun's core, taking millions of years to work its way to the surface, before racing across space at the speed of light, to warm the surfaces of distant worlds. The same photons that heated Earth's primordial oceans still carry energy to power photosynthesis in modern plants, connecting the ancient fusion reactions in our star's heart to every breath you take. Mercury, closest to this stellar hearth, develops its characteristic pattern of extreme temperature variations as it spins slowly through its 88-day orbit, one side baking in temperatures hot enough to melt lidded, while the opposite hemisphere freezes in the permanent shadow of the planet's own rotation. Imagine yourself hovering above Mercury's surface at the terminator line, where day meets night, feeling the dramatic temperature gradient that creates gentle winds in the planet's thin atmosphere, watching the slow progression of sunrise across the heavily cratered landscape that preserves a record of the early solar system's final bombardment. Venus emerges from its early formation period, wrapped in the thick clouds that will define its character for billions of years, the massive atmosphere creating a greenhouse effect, so powerful that surface temperatures soar higher than Mercury's, despite Venus's greater distance from the Sun. Yet this is not a harsh or forbidding process, but rather Venus expressing its own unique personality in the solar family, a world where atmospheric circulation moves with the stately rhythm of a planet that rotates backwards, where clouds of sulfuric acid create their own weather patterns in the upper atmosphere, while the surface below remains hidden beneath a blanket of carbon dioxide pressure, 90 times greater than Earth's. Breathe gently now, as you drift toward our own Earth in its golden age of development, watching as the blue-white world settles into the patterns of atmospheric and oceanic circulation that will make it the most geologically active and climatically diverse planet in our solar system. The early bombardment has ended, allowing Earth's surface to cool and solidify into the first stable continents, while volcanic outgassing continues to modify the atmosphere, adding water vapor that will condense into the vast oceans that cover most of the planetary surface. Earth's magnetic field, generated by the convection of molten iron in the planet's outer core, creates an invisible shield that deflects the solar wind and prevents our atmosphere from being slowly stripped away into space. Feel this protective embrace surrounding you like the gentlest of blankets as you breathe with the rhythm of Earth's magnetic field lines, watching the beautiful auroras that paint the polar skies when charged particles from the sun interact with our planet's magnetosphere. This magnetic protection allows Earth to retain its water and develop the complex atmospheric chemistry that will soon support the most remarkable phenomenon in the known universe, the emergence of living systems from non-living matter. The first hints of life appear in Earth's oceans, as simple chemical reactions begin to organize themselves into self-replicating patterns, molecules learning to make copies of themselves in the warm, mineral-rich waters near underwater volcanic vents. Picture these primordial seas not as empty expanses of water, but as vast laboratories where chemistry experiments with millions of different combinations and configurations, occasionally stumbling upon the precise arrangements that can maintain and reproduce themselves. The process occurs with the patience of geological time, each generation of molecular evolution building upon the successes of previous experiments across millions of years. Single-celled organisms gradually develop the ability to harness sunlight through photosynthesis, beginning the great transformation of Earth's atmosphere, from the carbon dioxide-rich mixture inherited from volcanic outgassing to the oxygen-rich environment that will eventually support complex multicellular life. Breathe slowly and feel yourself witnessing this gradual atmospheric transformation, each exhalation of oxygen by countless microscopic organisms, adding to the growing inventory of this reactive gas that will eventually create the ozone layer protecting Earth's surface from harmful ultraviolet radiation. Mars, during this same golden age, experiences its own period of peak habitability, as the red planet's thicker early atmosphere creates a greenhouse effect sufficient to keep water liquid on the surface. Rivers carve networks of valleys across the Martian landscape, while lakes and perhaps even shallow seas collect in the lower elevations, creating environments where Martian life might have evolved if the chemical conditions proved favorable. Imagine yourself standing on the shores of an ancient Martian lake, feeling the gentle lapping of liquid water against red sandy beaches, while methane and other gases in the early Martian atmosphere create spectacular sunsets that paint the sky in shades of orange and purple. The gas giants reach their full magnificence during this period, their atmospheric dynamics settling into the stable patterns of circulation that will persist for billions of years. Jupiter's Great Red Spot begins its centuries-long existence as a persistent storm system larger than Earth, while the planet's rapid rotation organizes atmospheric gases into the beautiful banded structure we recognize today. Different zones representing different chemical compositions, wind speeds, and cloud formation processes in the giant planet's hydrogen and helium atmosphere. Feel yourself floating peacefully above Jupiter's cloud tops, breathing gently with the rhythm of atmospheric bands that circle the planet at different speeds, watching lightning flashes illuminate the night side, while auroras dance around the magnetic poles in displays far more spectacular than anything Earth experiences. Jupiter's many moons perform their gravitational dance in perfect orbital resonances, with Io's volcanic geysers powered by tidal heating, Europa's subsurface ocean kept liquid by the same tidal forces, and Ganymede generating its own magnetic field through the convection of metallic materials in its core. Saturn's ring system reaches its peak complexity and beauty during this golden age. Countless ice particles organized into intricate patterns by the gravitational shepherding of small moons that orbit among the ring material. The rings are not uniform but divided into thousands of individual ringlets, each maintained by resonant relationships with Saturn's many moons, creating a structure so delicate and beautiful that it resembles cosmic jewelry fashioned by the patient working of gravitational forces over millions of years. Breathe slowly now, and imagine yourself among Saturn's rings, floating with ice particles that range in size from dust grains to house-sized boulders, all moving in perfect orbital harmony around the rapidly spinning planet below. The ring particles occasionally collide and stick together, or break apart, creating a dynamic equilibrium where the overall structure remains stable, even as individual components constantly change their relationships with one another. Titan, Saturn's largest moon, develops its thick nitrogen atmosphere and surface chemistry during this period, creating a world where methane rain falls from orange-colored clouds into hydrocarbon lakes and rivers that carve drainage patterns remarkably similar to Earth's water cycle. Yet this is chemistry operating at temperatures where water ice is as hard as rock, where liquid methane and ethane fill the role that water plays on Earth, creating landscapes of organic sand dunes and mountains of frozen water. The ice giants Uranus and Neptune express their own unique characteristics during this golden age, their deep blue-green atmospheres colored by methane that absorbs red light and reflects the shorter wavelengths back into space. Picture these distant worlds spinning in the cold outer reaches of the solar system, their magnetic fields tilted at unusual angles to their rotation axes, their seasons lasting decades as they slowly orbit the distant sun. Despite their great distance from the sun's warmth, both planets radiate more heat than they receive from solar radiation, suggesting active internal processes that continue to warm them from within. Neptune's winds reach speeds that exceed anything in the solar system, despite the planet's distance from the solar energy that drives atmospheric circulation, creating a meteorological mystery that demonstrates how each world develops its own internal dynamics, independent of external influences. Feel these distant winds as you breathe gently with Neptune's atmospheric circulation, imagining storms that race around the planet at speeds approaching 2,000 kilometers per hour, yet appear peaceful and serene when viewed from the perspective of deep space. The asteroid belt settles into its mature configuration during this period, with gravitational resonances creating the Kirkwood gaps, empty zones where Jupiter's influence prevents stable orbits, sweeping these regions clean of debris, while allowing asteroids to accumulate in neighboring areas. The largest asteroids like Ceres differentiate into core, mantle, and crust structures like miniature planets, while smaller bodies retain their primitive compositions as samples of the original materials from which the solar system formed. Breathe deeply now, as you contemplate this mature asteroid belt, feeling the gentle gravitational influences that organize tens of thousands of individual worldlets into families based on their orbital characteristics and compositions. Some asteroids are metallic remnants of planetary cores that were disrupted during the chaotic early period, while others preserve volatile materials including water ice and organic compounds that may have contributed to Earth's early atmospheric and oceanic inventories. Beyond Neptune, the Kuiper Belt and scattered disk populations establish their long-term stability during this golden age, with dwarf planets like Pluto, Eris, and Make settling into orbital relationships that will persist for billions of years. These distant worlds preserve samples of the original icy materials from the outer solar nebula, their surfaces barely modified by internal heating or external weathering, serving as time capsules that record the conditions present during solar system formation. Comets begin their patient vigil in the distant Oort cloud, arranged in a vast spherical shell that extends nearly halfway to the nearest star. Imagine these icy wanderers as sleeping messengers, drifting in the cold outer darkness for millions of years before gravitational perturbations from passing stars occasionally nudge them into new orbits that will carry them toward the inner solar system, as spectacular visitors bringing tales of the outer reaches. The heliosphere, the vast bubble of solar wind that surrounds our entire planetary family, reaches its maximum extent during this period, as our sun's stellar wind pressure balances against the interstellar medium that fills the space between stars. Feel this protective cocoon surrounding the entire solar system as you breathe gently with the rhythm of the solar wind, understanding how this invisible boundary shields our family of worlds from the harsher radiations of interstellar space, while allowing the gentler influences of nearby stars to reach us as gravitational perturbations and cosmic ray particles. Back on Earth, the Great Oxygenation Event gradually transforms the planetary atmosphere, creating conditions suitable for more complex forms of life, while simultaneously causing the first major extinction event as oxygen becomes toxic to many of the anaerobic organisms that dominated the early biosphere. Yet, this is not destruction but transformation, life learning new forms of metabolism that can harness the chemical energy stored in oxygen-containing molecules, eventually leading to the much more efficient cellular respiration that powers complex multicellular organisms. Breathe slowly now with the rhythm of this atmospheric transformation, feeling how each breath you take connects you to this ancient process of biological innovation. The oxygen in your bloodstream carries the same chemical energy that first became available to Earth's biosphere during this golden age of planetary evolution, when simple, single-celled organisms discovered how to transform sunlight into chemical energy, and began the process that would eventually lead to forests, coral reefs, and the magnificent diversity of life that characterizes our planet today. Continental drift begins to shape Earth's surface during this period, as the solid crust breaks into tectonic plates that drift slowly across the underlying mantle, creating new ocean basins while closing others, building mountain ranges through the gentle collision of continental masses, and creating the dynamic geological processes that will continue to reshape our planet's surface for billions of years to come. Feel the slow rhythm of tectonic motion as you breathe, understanding how these imperceptible movements over millions of years create the dramatic landscapes that define Earth's geography, mountain ranges rising like slow-motion waves, ocean basins opening and closing like Earth's geological breathing. This golden age represents the full flowering of our solar system's potential for diversity, beauty, and complexity, each world expressing its unique character while remaining connected to all the others through the gravitational relationships established during formation. As this section of our cosmic journey draws toward its gentle close, breathe deeply and feel yourself floating peacefully above this mature solar family, each planet glowing softly in reflected sunlight, each moon tracing its ancient orbital path, each small body following the gravitational choreography that will continue for billions of years. The stage is now set for the next chapters of solar system evolution, the gradual changes that will modify planetary climates, the continued evolution of life on Earth, the slow brightening of our sun as it ages, and the countless interactions between worlds that will create an ever-changing yet fundamentally stable cosmic community. Prepare now to witness how this mature system responds to the gentle challenges of time, breathing slowly as you drift forward through cosmic history toward the epochs of transformation and adaptation that lie ahead. Drift gently now through the slow-flowing river of geological time, carried forward by currents of stellar evolution and planetary change toward the long epoch of graceful maturation, when our solar family settles into the rhythms that will define its character for billions of years. Breathe slowly and deeply as you float through this period of gentle transformation, feeling how the dynamic processes established during the Golden Age now evolve into more subtle patterns of change that unfold with the patience of mountain building and the gradual brightening of stars. This is the time when worlds learn to weather the gentle challenges of cosmic evolution, when planetary systems demonstrate their remarkable resilience and capacity for adaptation across vast scales of space and time. Our Sun continues its steady nuclear burning, gradually converting hydrogen to helium in its core, and slowly brightening as the changing composition of stellar material affects the balance between gravitational compression and radiation pressure. Feel this subtle solar revolution as you breathe, each inhale representing millions of years of gentle change, each exhale carrying away the infinitesimal increases in solar luminosity that will eventually transform the climate conditions on all the planets. Yet this brightening occurs so slowly that billions of years will pass before it significantly affects the habitability of worlds like Earth and Mars, providing ample time for life and planetary systems to adapt to changing conditions. Earth enters its most stable period of climate regulation, as the biosphere develops sophisticated mechanisms for maintaining comfortable surface temperatures. Despite the gradually increasing solar output, the carbon cycle becomes a planetary thermostat, with atmospheric carbon dioxide levels naturally adjusting to balance the greenhouse effect against the brightening sun. More carbon dioxide trapped in rocks during warm periods, more released during cooler epochs, creating a natural feedback system that maintains liquid water oceans across billions of years. Breathe gently with this planetary breathing of carbon dioxide, in and out of the atmosphere in cycles that span millions of years. Volcanic activity releases carbon stored in rocks back to the atmosphere, while weathering processes draw atmospheric carbon into new rock formations, creating a slow circulation that connects Earth's solid crust, fluid oceans, gaseous atmosphere, and living biosphere in an integrated system of climate regulation that operates on timescales far longer than any individual organism's lifetime. Continental drift continues to reshape Earth's surface with the stately rhythm of tectonic motion, continents joining together into supercontinents and then breaking apart again in cycles that last hundreds of millions of years. Picture yourself floating high above Earth's surface, watching the slow-motion dance of continental plates as they drift across the mantle like lily pads floating on a slowly circulating pond. Mountain ranges rise and erode away, ocean basins open and close, creating new climatic patterns as land masses move through different latitudes and alter the circulation of atmospheric and oceanic currents. The supercontinent Rodinia assembles and disperses during this period, followed by the formation and breakup of Pannotia, and later Pangaea, each configuration creating different patterns of global climate and ocean circulation. Feel the rhythm of these tectonic cycles as you breathe slowly, understanding how the apparently solid Earth actually flows and changes like a very viscous liquid over geological time. Ice ages come and go as continental positions affect oceanic heat transport and atmospheric circulation, creating periodic cooling periods when glaciers advance from the poles toward lower latitudes, then warming periods when the ice retreats and sea levels rise. Life on Earth responds to these changing conditions not through struggle, but through patient adaptation, evolutionary processes, discovering countless creative solutions to the challenges posed by shifting climates, changing atmospheric compositions, and varying levels of solar radiation. Breathe gently with the rhythm of evolutionary time, feeling how each breath represents thousands of generations of organisms adapting to their environments, developing new forms of metabolism, new structures, new relationships with other living systems. The Cambrian explosion unfolds like a garden coming into bloom, life experimenting with complex multicellular forms, developing hard shells and skeletons that leave clear fossil records for the first time in Earth's history. Yet, this dramatic diversification occurs gradually over millions of years, life exploring new possibilities for organization and complexity, with the patience that characterizes all natural processes operating on cosmic timescales. Mass extinction events punctuate this long story of biological evolution, but these are not catastrophic endings, but rather gentle prunings that create opportunities for new forms of life to flourish. Picture these extinctions as autumn seasons in the garden of life, when some forms fade away to make space for new experiments in living, each ending creating the conditions for new beginnings. The end Permian extinction removes many marine species, but allows the ancestors of dinosaurs to diversify into terrestrial environments, while the end Cretaceous extinction creates niches that mammals will eventually fill with their own remarkable diversity. Breathe slowly now, as you drift beyond Earth to observe how other worlds mature during this same epoch. Mars gradually loses its thick early atmosphere as the planet's interior cools and its magnetic field weakens, allowing the solar wind to slowly strip away atmospheric gases over hundreds of millions of years. Yet this is not a violent process but a gentle transition. Mars settling into its current desert state like a garden entering dormancy, preserving beneath its surface the water ice and perhaps even microbial life that may persist in protected underground environments. The red planet's surface develops its characteristic features during this period: vast canyon systems carved by ancient water flows, enormous volcanic mountains built by slow accumulations of lava over millions of years, polar ice caps that grow and shrink with the planet's eccentric orbital cycles. Imagine yourself standing in one of Mars's ancient river valleys, feeling the ghost of water that once flowed here, sensing how the planet's geological processes continue at a slower pace beneath the current frozen surface. Venus settles into its mature state, with surface temperatures hot enough to melt lead, yet this extreme greenhouse effect represents the planet's own stable climate solution to its proximity to the Sun and the composition of its atmosphere. Volcanic activity continues to resurface the planet periodically, creating the relatively young surface we observe today, while maintaining the thick carbon dioxide atmosphere that defines Venus's character. Feel the stately rhythm of Venus's geological processes as you breathe, understanding how even this seemingly inhospitable world maintains its own form of environmental balance. Mercury experiences its own form of maturation, as tidal forces gradually slow the planet's rotation, until it becomes locked in a 3-2 resonance with its orbital period, completing 3 rotations for every 2 trips around the Sun. This creates Mercury's unique day-night cycle, where sunrise occurs twice at some locations, due to the planet's elliptical orbit and synchronized rotation. Picture Mercury's slow rotation creating its extreme temperature gradients, the day side baking in intense solar radiation, while the night side radiates heat away into the cold of space. The gas giants continue their own stately evolution during this period, their atmospheric dynamics reaching mature patterns that will persist for billions of years. Jupiter's Great Red Spot stabilizes as a persistent anticyclonic storm system, larger than Earth and powered by the planet's internal heat and rapid rotation. Breathe gently with Jupiter's atmospheric circulation, feeling how this massive storm represents the planet's way of organizing atmospheric energy into stable, long-lived patterns. Saturn's rings evolve through countless small interactions between ice particles and shepherding moons, creating the intricate structure of gaps and divisions we observe today. The rings are not permanent features but dynamic systems that constantly recycle their material, individual particles occasionally spiraling inward to fall into Saturn's atmosphere, while new material may be added by the disruption of small moons or captured comets. Feel the gentle rhythm of this ring evolution as you float peacefully above Saturn's equator, watching sunlight play across billions of ice particles that dance in gravitational harmony. Titan develops its complex atmospheric chemistry during this period, organic molecules forming in the upper atmosphere and raining down to create the hydrocarbon lakes and sand dunes that characterize this remarkable moon's surface. The nitrogen atmosphere and methane cycle create weather patterns remarkably similar to Earth's water cycle, but operating at temperatures where water ice is as hard as granite and liquid methane fills the role of water in creating rivers, lakes, and erosional processes. Imagine yourself standing on Titan's surface beneath orange-colored skies, feeling the gentle pressure of the thick nitrogen atmosphere, while methane drizzle falls from organic haze layers above. This alien chemistry demonstrates how similar physical processes can create familiar-looking landscapes using entirely different materials, showing the remarkable creativity of natural systems in organizing matter and energy into complex patterns. The ice giants Uranus and Neptune settle into their unusual magnetic field configurations during this period, with magnetic axes tilted at large angles to their rotation axes, possibly indicating that these planets experienced major impact events or unusual internal processes during their formation. Despite their great distance from the Sun, both worlds maintain active atmospheric systems powered by internal heat sources, creating wind patterns and storm systems that demonstrate the remarkable ability of planets to generate their own weather, regardless of external energy inputs. Feel the distant winds of these ice giants as you breathe slowly, understanding how atmospheric circulation continues even in the cold outer reaches of the solar system, where sunlight provides almost no heating. The energy driving these wind systems comes from the gradual cooling and contraction of the planetary interiors, gravitational energy slowly converted to heat, and then to atmospheric motion across billions of years. The smaller bodies of the solar system also mature during this period, with asteroid families organizing themselves based on ancient collision events that shattered larger parent bodies into fragments that still follow similar orbital paths millions of years later. Picture these asteroid families as cosmic relatives, groups of rocky worldlets that share common origins and continue to orbit the Sun together like extended families traveling through space. Meteorites from these asteroids occasionally reach Earth, carrying samples of the early solar system that allow scientists to study the conditions present during planetary formation. Comets establish their long-term orbital relationships during this period, with short-period comets trapped in regular orbits by gravitational interactions with Jupiter, while long-period comets continue to arrive from the distant Oort cloud on hyperbolic trajectories that carry them far beyond Pluto, before returning to the inner solar system centuries or millennia later. Breathe gently with the rhythm of these cometary orbits, feeling how these icy messengers connect the warm inner solar system to the cold outer reaches where they spend most of their time. The heliosphere continues to protect our solar family from interstellar radiation, while gradually changing its size and shape as our Sun moves through different regions of the local galactic environment. Our entire solar system orbits around the center of the Milky Way galaxy, with a period of about 225 million years, creating the galactic year that slowly carries us through regions of varying stellar density and cosmic ray intensity. Feel this grand orbital motion as you breathe slowly, understanding how our entire solar family travels together through the galaxy like a cosmic caravan, maintaining its internal relationships while slowly changing position relative to nearby stars and interstellar clouds. Ice ages on Earth may be partially influenced by these galactic motions, as our solar system passes through spiral arms and encounters different cosmic ray intensities that affect atmospheric chemistry and climate patterns. This epoch of graceful maturation demonstrates the remarkable stability of gravitational systems once they reach equilibrium configurations. As this section draws toward its gentle close, breathe deeply and feel yourself encompassed by the mature solar system in its full glory, each world settled into its characteristic patterns of behavior, each orbit precisely maintained by the balance of gravitational forces, each atmosphere and surface expressing the unique personality that emerges from the interplay of formation history, orbital position, and internal processes. The solar system has become a cosmic symphony, each world contributing its own voice to the gravitational harmony that connects all matter and motion in our corner of the galaxy. Prepare now to witness how this mature system responds to the challenges and changes that time will bring, breathing gently as you drift forward through the continuing story of planetary evolution, climate change, and the remarkable resilience that allows complex systems to persist and adapt across geological and astronomical timescales. Drift gently now through the meandering currents of cosmic time toward the epochs, when our solar family encounters the subtle challenges that test the resilience and adaptability of planetary systems across vast scales of space and time. Breathe slowly and deeply as you float through these periods of gentle adversity, understanding that what might appear as difficulties from one perspective represent opportunities for growth, adaptation, and the development of even greater stability and beauty from the patient perspective of geological time. These challenges arrive not as sudden catastrophes, but as gradual changes that unfold over millions and billions of years, allowing worlds and life itself to respond with the creativity and flexibility that characterize all natural systems. Our Sun continues its gradual brightening as nuclear fusion slowly changes the composition of the stellar core, helium ash accumulating from billions of years of hydrogen burning, and subtly altering the balance of forces that maintain stable energy output. Feel this stellar evolution as a gentle warming trend that spans geological time, each breath representing millions of years of slowly increasing solar luminosity. The change occurs so gradually that it provides ample opportunity for planetary atmospheres and biological systems to develop compensating mechanisms, yet it represents perhaps the most significant long-term challenge facing all worlds in our solar system. Earth's climate system responds to this solar brightening through the patient operation of feedback mechanisms that have regulated planetary temperature for billions of years. The carbonate-silicate cycle acts as a planetary thermostat, drawing carbon dioxide from the atmosphere when temperatures rise, storing it in rocks through enhanced weathering processes, then releasing it back through volcanic activity when cooling occurs. Breathe gently with this planetary breathing of carbon dioxide, in and out of the atmosphere across millions of years, feeling how Earth's climate system maintains liquid water oceans, despite the gradually changing energy input from the Sun. Ice ages arrive as regular visitors to Earth's climate system, triggered by subtle variations in the planet's orbital characteristics. The slow oscillation of orbital eccentricity, the gentle precession of rotational axis, and the patient nodding of obliquity that changes the angle of Earth's tilt relative to its orbital plane. Picture these orbital variations as a slow cosmic dance that creates rhythmic changes in the distribution of solar energy across Earth's surface, ice sheets growing and retreating, like the planet's seasonal breathing stretched across hundreds of thousands of years. These Milankovitch cycles create opportunities rather than problems. Ice ages opening new evolutionary niches as sea levels fall, and land bridges appear between continents, while interglacial periods allow tropical and temperate ecosystems to expand into previously frozen regions. Feel the rhythm of these climate cycles as you breathe slowly, understanding how life responds to changing conditions not through struggle but through patient adaptation, species migrating to follow suitable habitats as they shift across the landscape. Continental drift continues to reshape Earth's surface, the slow collision of tectonic plates creating mountain ranges, volcanic activity, and gradual changes in ocean circulation patterns that influence global climate over millions of years. The formation of the Himalayas and other major mountain ranges alters atmospheric circulation, while creating new environments for evolutionary experimentation at high altitudes and in rain shadows. Breathe with the patient rhythm of mountain building, each inhale representing the slow compression of crustal materials, each exhale the gradual uplift that creates new landscapes over geological time. Volcanic activity associated with tectonic motion releases gases that modify atmospheric composition while creating new land surfaces, and occasionally triggering temporary climate changes through ash and gas emissions that dim sunlight for brief periods in geological terms. Mass extinction events punctuate Earth's biological history like chapter breaks in the long story of life's evolution. Yet these apparent endings always lead to new beginnings as surviving species diversify to fill empty ecological niches. Picture these extinctions as natural prunings in the garden of life, creating space for new forms of biological creativity to flourish. The end Ordovician glaciation removes many marine species, but allows life to begin its tentative exploration of terrestrial environments, while the end Permian extinction clears ecological space for the age of reptiles to begin. Each extinction event demonstrates life's remarkable resilience and creativity, survivors developing new strategies for metabolism, reproduction, and environmental adaptation that often prove more sophisticated than those of their predecessors. Feel the patient resilience of life as you breathe gently, understanding how biological systems respond to challenges by exploring new possibilities rather than simply trying to maintain old patterns. The survivors of mass extinctions often evolve rapidly to exploit newly available resources, creating periods of evolutionary innovation that add new layers of complexity and beauty to Earth's biosphere. Mars faces its own gradual challenges as the planet's interior cools and its magnetic field weakens, allowing the solar wind to slowly erode the Martian atmosphere over hundreds of millions of years. Yet this transformation occurs so gradually that any life forms that may have evolved in Mars's early warmer period would have had ample time to adapt to changing conditions, perhaps retreating to subsurface environments where liquid water and stable temperatures persist even today. Imagine yourself descending below Mars's current frozen surface, feeling the gradual warming as you move away from the harsh surface conditions toward the possibly habitable zones that may exist in underground aquifers and geothermal systems. The red planet's polar ice caps continue to grow and shrink with seasonal and longer-term climate cycles, demonstrating that planetary systems continue to remain dynamic and responsive even after major atmospheric changes. Venus experiences its own form of environmental challenge, as volcanic resurfacing events periodically remake large portions of the planet's surface. Yet these dramatic geological processes represent Venus's way of releasing internal heat and maintaining geological activity, despite the planet's extreme surface conditions. The thick atmosphere that creates Venus's greenhouse effect also provides pressure that allows volcanic processes to operate differently than they do on Earth, creating unique landforms and geological features. Feel the patient rhythm of Venus's geological activity as you breathe slowly, understanding how even extreme conditions can support ongoing planetary processes that maintain dynamic equilibrium over geological time. The planet's retrograde rotation may result from ancient impact events or tidal interactions, yet Venus has adapted to this unusual spin by developing atmospheric circulation patterns that transport heat efficiently from day side to night side, despite the very slow rotation period. The gas giants face their own evolutionary challenges, as their atmospheric dynamics respond to the gradually changing energy balance between internal heat sources and external solar heating. Jupiter's Great Red Spot undergoes periodic changes in size, color, and intensity, demonstrating how even the most stable atmospheric features must adapt to slowly changing conditions while maintaining their essential character across centuries of observations. Picture yourself floating peacefully above Jupiter's cloud tops, breathing gently with the rhythm of atmospheric circulation. As storm systems merge and separate, bands of different colored clouds shift their boundaries, and the planet's weather patterns demonstrate the creative ways that fluid systems respond to changing energy inputs. The internal heat that drives Jupiter's atmospheric circulation gradually decreases as the planet continues to contract and cool, yet new circulation patterns emerge to maintain the dynamic atmospheric systems that characterize this giant world. Saturn's rings face ongoing challenges from gravitational perturbations, meteoroid bombardment, and the slow spiral of ring material toward the planet's atmosphere. Yet these apparently destructive processes are balanced by the creation of new ring material from disrupted moons and captured debris. Feel the dynamic equilibrium of Saturn's ring system as you breathe slowly, individual particles following complex orbital dances, while the overall structure maintains its beauty and stability across millions of years. The shepherd moons that help maintain ring structure occasionally experience close encounters or orbital changes that temporarily disrupt ring organization, yet gravitational forces always work to restore stability, and often create even more intricate patterns of gaps, divisions, and resonant structures. These ring dynamics demonstrate how complex systems can maintain their essential character while continuously adapting to changing circumstances. Breathe gently now as you contemplate how the ice giants Uranus and Neptune respond to their own challenges in the cold outer solar system. These distant worlds experience the most subtle solar heating variations as they complete their decades-long orbital periods, yet their atmospheric systems remain remarkably active, powered primarily by internal heat sources that gradually decrease over geological time. Seasonal changes on these worlds unfold over decades rather than months, creating opportunities for long-term atmospheric adaptation that differs dramatically from the rapid weather changes on inner planets. Picture Uranus's extreme seasons where each pole experiences decades of continuous sunlight followed by decades of darkness, creating atmospheric circulation patterns unlike anywhere else in the solar system. These extreme seasonal cycles demonstrate how planetary systems can adapt to unusual conditions while maintaining atmospheric activity and weather patterns. The smaller bodies of the solar system face ongoing challenges from gravitational perturbations, collisions, and orbital evolution. Yet these processes also create opportunities for renewed activity and surface modification. Asteroids occasionally experience close encounters with planets or other asteroids that alter their orbits and expose fresh surface materials, while comets undergo dramatic changes during their periodic approaches to the Sun as volatile materials sublimate and create the spectacular comas and tails that make them visible from Earth. Feel the patient persistence of these small worlds as you breathe slowly, understanding how objects ranging from tiny meteoroids to dwarf planets maintain their essential character while adapting to the changing gravitational environment of the evolving solar system. Some asteroids develop their own tiny moons through gentle collisions or gravitational capture, while others fragment and reform, demonstrating the ongoing creativity of gravitational processes in organizing matter into new configurations. External cosmic influences provide additional gentle challenges, as our entire solar system moves through different regions of the galaxy during its 225 million-year orbital period around the galactic center. Passage through spiral arms exposes our solar system to increased cosmic ray radiation and gravitational perturbations from nearby stars, while traversal of less dense regions provides periods of relative calm and stability. Picture our solar family as cosmic travelers, maintaining their internal relationships while journeying together through the changing galactic environment. Occasional encounters with other star systems create subtle perturbations in the Oort cloud that may trigger increased comet activity, while variations in cosmic ray intensity influence atmospheric chemistry and climate patterns on planets with substantial atmospheres. These cosmic influences remind us that our solar system exists within a larger galactic community, connected to the broader universe through gravitational, electromagnetic, and particle interactions that operate across vast scales of space and time. Breathe gently with the rhythm of galactic motion, feeling how our local family of worlds participates in the larger cosmic dance, while maintaining the intimate relationships that make each planet unique and special. Through all these challenges, both internal and external, our solar family demonstrates the remarkable stability and adaptability that characterize mature gravitational systems. As this section draws toward its peaceful close, breathe deeply and feel yourself encompassed by the resilient beauty of worlds that have learned to thrive, despite changing conditions, each planet finding its own creative solutions to the gentle challenges of cosmic evolution. The very existence of these challenges creates opportunities for continued growth, adaptation, and the development of even greater complexity and beauty over cosmic time. Prepare now to witness how our solar system's story will continue to unfold across the vast future that lies ahead, breathing slowly as you drift forward through deep time toward the distant epochs, when our sun itself will transform and our family of worlds will face the ultimate test of their resilience and adaptability. Drift gently now into the flowing river of deep future time, carried forward by currents of stellar evolution toward the distant epochs, when our sun itself will begin its greatest transformation, and our family of worlds will dance through changes so profound yet so gradual that they unfold like the slowest of cosmic ballets across billions of years. Breathe slowly and deeply as you float through these future eons, feeling how time itself becomes a gentle medium through which the most magnificent transformations occur with infinite patience, understanding that what lies ahead is not ending but metamorphosis, not destruction but the beautiful unfolding of stellar and planetary destiny written in the fundamental laws of physics and the patient working of cosmic forces. Our sun, now middle-aged at roughly 5 billion years of steady nuclear burning, will continue its reliable hydrogen fusion for another 5 billion years, gradually brightening as helium accumulates in the stellar core and slowly alters the balance of gravitational compression and radiation pressure. Feel this stellar aging process as you breathe gently, each breath representing millions of years of continued solar evolution. The same nuclear fires that warm Earth today, destined to burn with increasing intensity as our star approaches the next phase of its cosmic life cycle. Yet this brightening occurs so slowly that life and planetary systems will have ample time to adapt, just as they have successfully navigated all previous environmental changes. As solar luminosity increases over the coming billion years, Earth's climate system will face its greatest test, the carbonate-silicate cycle working ever more intensely to remove carbon dioxide from the atmosphere and prevent runaway greenhouse warming. Picture Earth's patient climate regulation system adapting to the brightening sun like a planetary thermostat, making increasingly fine adjustments to maintain comfortable surface temperatures. Enhanced weathering processes will draw more atmospheric carbon into rock formations, while volcanic activity continues to release carbon back to the atmosphere, the planet breathing more rapidly as it works to maintain the delicate balance that preserves liquid water oceans. Eventually, perhaps 1 billion years in the future, Earth's oceans will begin their slow evaporation as the increasing solar heat overwhelms even the most sophisticated climate regulation mechanisms. Yet imagine this transformation not as catastrophic loss, but as Earth's gradual transition from blue water world to a different type of beauty, water vapor rising into the upper atmosphere, where ultraviolet radiation will slowly dissociate molecules and allow hydrogen to escape to space while oxygen combines with surface rocks. This process will unfold over hundreds of millions of years, providing time for life to adapt or perhaps to spread to other worlds where conditions remain suitable for biological processes. Mars may experience a second spring during this period of increased solar brightness, subsurface ice deposits melting as the red planet receives more heat from our aging sun. Breathe slowly as you imagine ancient Martian riverbeds flowing with water once again, polar ice caps melting to release water vapor that thickens the atmosphere and creates the greenhouse effect necessary to maintain liquid water on the surface. This Martian renaissance could last for millions of years, creating temporary seas in the planet's northern lowlands, while volcanic activity releases additional gases that help maintain atmospheric pressure. The moons of the gas giants will also experience their own transformations, as increased solar heating reaches the outer solar system. Europa's ice shell may thin or disappear entirely, revealing the subsurface ocean that has remained hidden beneath kilometers of ice for billions of years. Picture Europa as an ocean world under open skies, its surface waters reflecting the light of the distant but brightening sun, while tidal forces from Jupiter continue to drive geological activity on the ocean floor. This oceanic period could provide ideal conditions for any life forms that may have evolved in Europa's hidden seas. Titan will undergo its own atmospheric evolution, as the increased solar energy drives more vigorous circulation in the thick nitrogen atmosphere, possibly creating more active weather patterns and enhanced organic chemistry in the upper atmosphere. Feel Titan's atmospheric changes as you breathe gently, imagining how increased energy input could accelerate the methane cycle and create more dramatic seasonal variations on this remarkable world. The hydrocarbon lakes and rivers may become more active, while new organic compounds form in the energized atmosphere, creating an even richer chemical environment than exists today. As you continue breathing slowly with the rhythm of deep future time, prepare to witness the most magnificent transformation in our solar system's history, the evolution of our Sun from its current stable main sequence phase to the red giant stage that will define its next billion years of existence. This transformation begins subtly in the solar core, as hydrogen fuel becomes depleted and nuclear fusion gradually shifts to a shell around an increasingly helium-rich center. The Sun's outer layers will begin their patient expansion like a flower blooming in ultra-slow motion, the stellar surface cooling and reddening as it moves farther from the nuclear furnace at the core. Picture this expansion not as explosive growth, but as the gentlest possible stretching, solar materials flowing outward with the stately rhythm of stellar evolution, taking millions of years to double the Sun's radius and hundreds of millions of years to reach maximum size. The red giant phase represents not death, but transformation, our star expressing a different aspect of its nuclear personality. During the early stages of red giant evolution, the Sun's increased size and luminosity will create extraordinary conditions throughout the solar system. Mercury, closest to our transforming star, will likely be engulfed by the expanding solar atmosphere, its materials vaporized and incorporated into the stellar wind that flows outward from the red giant's extended surface. Yet, imagine Mercury's ending not as destruction, but as homecoming, the planet's atoms returning to the stellar medium from which they originally formed, completing a cosmic cycle of matter that spans billions of years. Venus may also be consumed by the expanding red giant, or it may survive in a much more distant orbit as gravitational interactions with the expanding solar envelope and increased solar wind mass loss cause planetary orbits to spiral outward. Breathe gently with these orbital changes, feeling how gravitational relationships adjust to accommodate the Sun's transformation while maintaining the essential architecture that defines our solar family. Even dramatic changes unfold, gradually enough that orbital mechanics can adapt and find new equilibrium configurations. Earth faces an uncertain future during the red giant phase. Some models suggest our planet will be consumed by the expanding solar atmosphere, while others indicate it may survive in a more distant orbit, transformed beyond recognition, but still maintaining its identity as a world orbiting our star. Picture Earth's possible survival as a testament to the resilience of gravitational relationships, our planet finding a new orbital dance that allows it to persist even as the Sun transforms around it. Any life that survives this transition would need to adapt to radically different conditions, or perhaps migrate to more suitable environments elsewhere in the solar system. Mars will almost certainly survive the red giant phase, its orbit carrying it safely beyond the reach of the expanding solar atmosphere. The increased luminosity from the red giant sun will create tropical conditions on Mars for hundreds of millions of years, melting all subsurface ice and creating thick atmospheres and possibly vast oceans. Imagine Mars as a blue-green world during this distant epoch, clouds forming over newly filled ocean basins, while a thick atmosphere maintains comfortable surface temperatures, even at the planet's current distance from the Sun. The gas giants will experience their own transformations as the red giant sun heats their upper atmospheres and drives enhanced circulation patterns in their hydrogen and helium envelopes. Jupiter may lose some of its atmospheric mass to the intensified solar wind, while its many moons experience radical environmental changes as they receive hundreds of times more energy than they do today. Feel the transformation of Jupiter's moons as you breathe slowly, Ganymede and Callisto developing substantial atmospheres as their icy surfaces sublime, while Io's volcanic activity increases dramatically in response to enhanced tidal heating from Jupiter's changing structure. Europa's ocean will exist under open skies with surface temperatures that may support Earth-like biochemistry, while new moons may form from captured debris in the changing gravitational environment around the giant planet. Saturn's magnificent ring system may undergo dramatic changes during the red giant phase, increased solar heating and radiation pressure affecting the orbital dynamics of ring particles, while enhanced atmospheric escape from Saturn itself provides new material for ring formation. Picture Saturn's rings transforming like cosmic weather patterns, existing structures dissolving and reforming in new configurations, as the changing energy balance alters the delicate gravitational and electromagnetic forces that maintain ring stability. The ice giants Uranus and Neptune, far from the red giant sun, may experience their first truly warm period in billions of years as solar luminosity increases by factors of hundreds or thousands. Their icy moons will melt completely, creating temporary ocean worlds in the outer solar system, while thick atmospheres develop around worlds that have remained frozen since their formation. Breathe gently as you imagine these distant transformations, understanding how the red giant phase creates opportunities for entirely new forms of planetary evolution in regions of the solar system that have remained cold and inactive for billions of years. Worlds that never experienced liquid water may develop their own unique forms of surface activity and atmospheric circulation during this remarkable period of enhanced solar energy. Eventually, after hundreds of millions of years as a red giant, our sun will begin to shed its outer layers in a series of gentle pulsations, not explosive ejections but rhythmic exhalations that gradually remove the extended stellar atmosphere and reveal the hot, dense core beneath. Picture this process as the sun breathing out its outer layers like dandelion seeds carried on cosmic winds, creating an expanding shell of glowing gas that will become a beautiful planetary nebula visible from other star systems. The stellar core that remains will be a white dwarf star, no larger than Earth, but containing about half the sun's original mass, compressed into an incredibly dense object that will cool slowly for trillions of years. Feel the peaceful transformation as the white dwarf settles into its long cooling phase, like an ember from a cosmic campfire that will glow softly in the darkness for eons beyond any current measure of time. This remnant of our sun will continue to provide gravitational anchor for any surviving planets while slowly radiating away its stored heat energy. The surviving planets will adjust their orbits to the white dwarf's reduced mass, settling into new gravitational relationships that may persist for billions of years. Breathe slowly as you imagine this transformed solar system, worlds orbiting the white dwarf remnant of our sun in modified but stable paths, their surfaces lit by the gentle glow of the cooling stellar ember. Some planets may develop new forms of activity, powered by tidal heating or residual radioactivity, while others settle into peaceful dormancy under the white dwarf's fading light. The planetary nebula created by the sun's outer layer ejection will expand slowly through space, enriching the interstellar medium with heavy elements forged during billions of years of nuclear fusion. Picture this expanding shell of glowing gas as our solar system's gift to the galaxy, carbon and oxygen and nitrogen atoms that will eventually be incorporated into new generations of stars and planets, continuing the cosmic cycle of stellar birth, evolution and renewal. Even in this transformed state, our solar system will maintain its essential identity as a gravitationally bound family of worlds, the white dwarf sun continuing to hold its planetary companions in orbital dance for trillions of years. As this section draws toward its gentle close, breathe deeply and feel yourself encompassed by the profound patience of cosmic evolution, understanding how transformation and continuity coexist in the patient working of natural forces across vast scales of space and time. The story of stellar evolution reminds us that endings are also beginnings, that the materials of our solar system will continue to participate in cosmic processes long after our sun's nuclear fires have cooled to ember glow. Prepare now to witness how human understanding and scientific discovery have illuminated these cosmic processes, breathing slowly as you drift toward the final chapters of our journey through the solar system's past, present, and future. Greek philosophers proposed that Earth itself might be a wandering star, a revolutionary concept that placed our world among the celestial objects, rather than fixed at the center of creation. Aristarchus of Samos suggested that Earth orbits the sun, an insight so radical that it would be largely forgotten until rediscovered centuries later. Feel the courage required for such cosmic thinking, minds expanding to encompass perspectives that challenge the most fundamental assumptions about Earth's place in the universe. Ancient peoples worldwide recognized the planets as wandering stars, different from the fixed stellar patterns that wheeled overhead with the seasons. Babylonian astronomers 4,000 years ago tracked Venus through its synodic cycles with patient devotion, their cuneiform tablets recording the morning and evening appearances of the goddess Ishtar, as she danced between Earth and Sun in orbital rhythms that would not be understood until much later in human history. Picture these early star watchers standing beneath desert skies, feeling the same wonder at planetary motion that connects you to the cosmic dance even today. Drift gently now through the flowing currents of human curiosity and discovery, returning from the vast perspectives of cosmic time, to witness how conscious minds have gradually awakened to the beauty and complexity of our solar family. Each generation of observers, adding new verses to humanity's growing song of cosmic understanding. Breathe slowly and deeply as you float through the history of astronomical discovery, feeling how human consciousness represents the universe becoming aware of itself, star stuff organized into thinking matter capable of contemplating the very processes that created it. This awakening of cosmic consciousness occurs across cultures and centuries, each observer contributing their own unique insights to the collective human understanding of our place in the cosmic community. Medieval Islamic scholars preserved and expanded upon Greek astronomical knowledge, like tenders of a cosmic garden, their observatories in Baghdad, Cordoba, and Samarkand mapping planetary positions with unprecedented accuracy, while developing mathematical techniques that would eventually enable the precise prediction of celestial motions. Al-Battani refined measurements of Earth's orbital period, while Ibn al-Haytham pioneered experimental methods that would later inspire the scientific revolution. Galileo's telescope opened human eyes to the detailed structure of our solar family, revealing Jupiter's 4 largest moons in their orbital dance around the giant planet, proving that not all celestial objects orbit Earth. Imagine the wonder of seeing these tiny points of light change position from night to night, demonstrating that other worlds have their own satellite companions just as Earth has its moon. Venus showed phases like Earth's moon, confirming that it orbits the Sun rather than Earth, while Saturn's mysterious appearance suggested additional complexity that would later resolve into the beautiful ring system we recognize today. Breathe gently with the patience of these medieval astronomers, understanding how knowledge accumulates across generations like sedimentary layers of understanding, each observer building upon the work of predecessors, while adding their own contributions to humanity's growing comprehension of cosmic architecture. Their careful observations provided the foundation for later discoveries that would revolutionize human understanding of planetary motion and gravitational forces. The discovery of Uranus by William Herschel expanded the known solar system beyond ancient boundaries, proving that worlds remain to be discovered beyond the planets known to antiquity. Feel the excitement of cosmic exploration as human knowledge expanded to encompass ice giant worlds spinning in the cold outer reaches of the solar system. Neptune's discovery through mathematical prediction based on gravitational perturbations demonstrated the power of physical theory to reveal hidden aspects of cosmic architecture before direct observation could confirm their existence. Newton's universal law of gravitation provided the physical explanation for Kepler's mathematical harmonies, revealing that the same force responsible for Earth's surface gravity guides planetary orbits, comet trajectories, and tidal flows. Picture gravity as the invisible thread that connects all matter in the universe, from the apple falling in Newton's garden to the vast orbital dances of planets and stars. This insight transformed human understanding from descriptive astronomy to predictive celestial mechanics, enabling precise calculations of planetary positions and the discovery of new worlds through gravitational influence alone. Kepler's mathematical genius revealed the underlying music of planetary motion, discovering that orbital paths follow elliptical rather than circular trajectories, and that planets sweep out equal areas in equal time as they speed up and slow down in their journeys around the Sun. Feel the harmony of Kepler's laws as you breathe slowly, understanding how mathematical relationships describe the gravitational choreography that connects all orbital motion in our solar system. The mathematical poetry of planetary motion revealed deep underlying principles that would later guide spacecraft trajectories and enable human exploration of other worlds. Photography revolutionized astronomical observation, allowing permanent records of planetary appearances, asteroid discoveries, and cometary spectacles that could be studied long after the observing opportunity had passed. Breathe gently as you imagine the first photographs of planetary surfaces, fuzzy images that nevertheless revealed permanent features like Mars's polar ice caps and the changing cloud patterns on Jupiter and Saturn. These early images connected human vision to worlds millions of kilometers away, making distant planets feel more real and accessible to scientific investigation. Spectroscopy opened an entirely new window into planetary compositions and atmospheric conditions, allowing astronomers to analyze the chemical makeup of worlds they could never visit directly. The absorption lines in reflected planetary light revealed atmospheric gases, while thermal emission provided information about surface temperatures and internal heat sources. Picture spectroscopy as a form of cosmic chemistry, allowing human minds to analyze the elemental composition of distant worlds through the messages carried by starlight and reflected sunlight across vast distances. The space age transformed planetary science from remote observation to direct exploration, robot ambassadors carrying human curiosity to every major world in our solar system. Feel the excitement of vicarious exploration as you breathe slowly, spacecraft serving as extensions of human senses, allowing us to see, touch, taste, and analyze the surfaces and atmospheres of other worlds. Each mission revealed unexpected discoveries that challenged theoretical predictions and expanded understanding of planetary diversity and evolution. The Voyager spacecraft carried golden records containing human music, voices, and images, messages in bottles cast into the cosmic ocean that will outlast human civilization and perhaps someday be discovered by other intelligent beings. Picture these spacecraft as humanity's first interstellar ambassadors, carrying greetings from Earth beyond the heliosphere and into the realm of other stars. Their continuing journey into interstellar space represents humanity's first tentative steps toward becoming a spacefaring species capable of exploring beyond our solar system. Pioneer and Voyager missions provided the first close-up views of the gas giants, revealing Jupiter's complex atmospheric dynamics, Europa's smooth ice surface suggesting subsurface oceans, and Saturn's intricate ring structure, with thousands of individual components. Breathe gently with the rhythm of these grand tour missions, feeling how spacecraft trajectories used gravitational assists from one planet to reach the next, dancing through the solar system like human-made comets, following precisely calculated paths. These missions transformed gas giants from telescopic curiosities to complex worlds, with their own weather patterns, magnetic fields, and diverse moon systems. Mariner and Viking spacecraft revealed Mars as a world of ancient riverbeds and massive volcanoes, polar ice caps and dust storms that occasionally embrace the entire planet. Picture these robotic explorers as patient observers, sending postcards from the Martian surface that showed red sunsets, frost-covered rocks and landscapes that resembled earthly deserts yet possessed their own alien beauty. The search for past or present Martian life became a central focus of planetary science, connecting the study of other worlds to fundamental questions about the nature and distribution of living systems. Modern robotic missions continue to reveal the complexity and beauty of our solar system neighbors, from the subsurface oceans of icy moons to the organic chemistry of Titan's atmosphere, from the geological activity of asteroid surfaces to the dynamic plasma interactions between planetary magnetospheres and the solar wind. Breathe gently as you contemplate how each new discovery adds verses to humanity's cosmic song, revealing unexpected connections between worlds and processes that demonstrate the fundamental unity underlying solar system diversity. The search for extraterrestrial life has become a central theme connecting planetary science, biology, and chemistry, with missions specifically designed to investigate the habitability of other worlds and search for signs of past or present biological activity. Picture this search as humanity listening for other voices in the cosmic conversation, seeking evidence that life represents not a unique earthly accident, but a natural consequence of chemistry and physics operating under suitable conditions. Every discovery of water, organic compounds, or energy sources on other worlds expands the potential for biological processes to emerge and flourish throughout the solar system. Hubble Space Telescope and other space-based observatories extended human vision beyond the solar system, discovering thousands of exoplanets orbiting other stars and revealing that planetary systems are common throughout the galaxy. Feel the expansion of cosmic perspective as you breathe slowly, understanding how the discovery of other planetary families confirmed that our solar system represents just one example of cosmic architecture, among countless others. The diversity of exoplanetary systems revealed new possibilities for planetary formation and evolution, while highlighting the special characteristics that make our own solar family unique. Computational models and laboratory experiments now allow scientists to recreate the conditions present during solar system formation, testing theories of planetary accretion, atmospheric evolution, and climate change against the observational evidence gathered by telescopes and spacecraft. Feel the convergence of observation, experimentation, and theory as you breathe slowly, understanding how human understanding grows through the patient accumulation of evidence and the creative development of explanatory frameworks that connect individual discoveries to broader patterns. Current research into astrobiology, planetary protection, and space resource utilization reflects humanity's growing recognition that our future may be intimately connected to our relationship with other worlds in our solar system. Breathe gently as you contemplate how scientific discovery serves not only curiosity, but also practical goals of ensuring human survival and expansion throughout the cosmic community that surrounds us. The same understanding that allows us to appreciate the beauty of planetary motion also provides the foundation for spacecraft navigation, resource utilization, and perhaps eventually human settlement on other worlds. International cooperation in space exploration, demonstrates how cosmic perspective can transcend earthly divisions, bringing together scientists and engineers from different nations in common cause of extending human presence and understanding throughout the solar system. Picture the International Space Station as a symbol of this cooperation. Humans from different cultures working together in the cosmic environment that connects Earth to the broader community of worlds. Space exploration represents humanity at its best, combining technical excellence with scientific curiosity and international collaboration. Educational programs and public outreach bring the excitement of planetary science to new generations, fostering the curiosity and technical skills that will be needed for future exploration and discovery. Breathe gently as you imagine young minds encountering the wonders of the solar system for the first time, their excitement and questions driving the next waves of exploration and understanding. Science education represents an investment in humanity's cosmic future, preparing minds capable of solving the challenges of interplanetary exploration and settlement. As this section of our journey through human understanding draws toward its gentle close, breathe deeply and feel yourself connected to the entire history of cosmic curiosity, from ancient star watchers to modern space explorers, all united by wonder at the beauty and complexity of our solar family. Each generation builds upon the discoveries of previous observers, while adding their own insights to the growing tapestry of human knowledge about our place in the cosmic community. Amateur astronomers and citizen scientists continue to contribute important discoveries, from asteroid detection to exoplanet confirmation, demonstrating how cosmic curiosity remains accessible to anyone willing to look up at the night sky with wonder and patience. Feel the democratic nature of astronomical discovery as you breathe slowly, understanding how the cosmic perspective belongs not just to professional scientists but to anyone curious about our place in the universe. The same stars that inspired ancient mythologies continue to inspire modern exploration and discovery. The legacy of human understanding includes not only factual knowledge about planetary orbits, atmospheric compositions and geological processes, but also the deeper wisdom that comes from recognizing our kinship with other worlds and our responsibility as conscious beings capable of appreciating and protecting the cosmic environment we inhabit. Prepare now for the final movement of our cosmic symphony, breathing slowly as you drift toward the eternal perspectives that encompass all of human discovery within the broader context of cosmic evolution and the patient working of natural forces across infinite scales of space and time. Even as our sun eventually completes its red giant phase and settles into its long existence as a white dwarf, cooling slowly through trillions of years that dwarf the current age of the universe itself, the fundamental patterns that shaped our solar family will persist in forms beyond current imagination. Picture the white dwarf sun glowing softly like a cosmic ember, providing gentle illumination for any worlds that continue their orbital dances in the transformed solar system. Gravitational relationships will maintain their essential harmonies even as the energy sources that powered atmospheric circulation and geological activity gradually fade into the whispered interactions of cooling matter and the quantum fluctuations of empty space. Drift gently now into the infinite embrace of cosmic eternity, carried by the deepest currents of space and time toward perspectives so vast and peaceful that all the stories we have shared, of stellar birth and planetary formation, of climate change and biological evolution, of human discovery and future transformation, settle into their proper places as movements in an eternal symphony that has no beginning and will have no end. Breathe slowly and deeply now, allowing each breath to carry you further into the profound tranquility that encompasses all change, all growth, all transformation, within the patient rhythm of cosmic processes that operate beyond any individual timeline. Here in the gentle twilight of our journey through solar system time, we find the deepest peace in understanding our eternal connection to the dance of matter and energy that creates and sustains all worlds, all life, all consciousness throughout the universe. The materials that comprise our solar system, every atom of iron in planetary cores, every molecule of water in ancient oceans, every carbon atom that once participated in the chemistry of life, will continue their participation in cosmic processes long after stellar fusion has ceased and planetary atmospheres have dissipated into the near vacuum of interstellar space. Feel the eternal nature of these atomic building blocks as you breathe gently, understanding how matter and energy can change form but never truly disappear, always finding new ways to organize themselves into patterns of ever greater beauty and complexity. Yet, even in this ultimate cosmic autumn, when the last black holes have evaporated and the universe has settled into its maximum entropy state of uniformly distributed elementary particles and radiation, the quantum vacuum itself remains active with virtual particle creation and annihilation, maintaining the potential for new forms of organization and complexity to emerge from apparent emptiness. Feel the eternal creativity of existence itself as you breathe peacefully, understanding how endings always contain the seeds of new beginnings, how apparent emptiness preserves infinite potential for future manifestation. Even in the far future, when galaxies have separated beyond mutual gravitational influence and star formation has ceased for lack of raw materials, when the universe has expanded and cooled, until only the most long-lived stars remain as islands of warmth in an ocean of darkness, the mathematical relationships that govern orbital motion will continue to operate in whatever structures persist in that distant cosmic twilight. Breathe slowly with the rhythm of eternal time, understanding how the same gravitational harmonies that connect Earth to Moon, planets to Sun, and solar system to galaxy will continue to create order and beauty, regardless of the specific materials involved. Black holes, should any form from the evolution of massive stars in our galactic neighborhood, will eventually evaporate through Hawking radiation over timescales so vast that they make the current age of the universe seem like a single heartbeat. Yet even this most gradual of processes follows precise mathematical laws and returns organized matter to the quantum fields that underlie all physical reality. Picture this ultimate recycling as the gentlest possible dissolution, complex structures returning to fundamental simplicity while preserving the information and relationships that defined their existence. Our journey through solar system time has revealed the intimate connections between the largest and smallest scales of existence, how the nuclear physics operating in stellar cores creates the elements essential for rocky planets and biological processes, how quantum mechanics governs the chemical bonds that allow atmospheric and oceanic circulation, how gravitational dynamics on galactic scales influence the formation and evolution of individual planetary systems. Feel these connections as threads in a cosmic tapestry that includes your own existence, your own consciousness, your own capacity for wonder and understanding, as expressions of the universe becoming aware of itself. The story of our solar system, from its birth in the collapse of a molecular cloud, through its mature stability and eventual transformation during stellar evolution, represents just one verse in an infinite cosmic song that includes countless other planetary families, other forms of complexity, other experiments in the organization of matter and energy into beautiful and meaningful patterns. Breathe gently as you expand your awareness to encompass all possible worlds, all possible forms of cosmic architecture, all possible expressions of the creative forces that transform simple materials into complex, beautiful, conscious systems. The same carbon atoms that form the backbone of organic molecules on Earth have participated in countless other molecular structures throughout cosmic history, perhaps once part of the atmosphere of a red giant star, perhaps locked in the frozen nucleus of a comet for billions of years, perhaps dissolved in the primordial oceans where life first began its patient experimentation with self-replication and metabolism. Breathe slowly now and feel your kinship with every atom in your body, star stuff temporarily organized into the complex pattern we call human consciousness, capable of contemplating the very cosmic processes that created you. Your capacity for wonder at planetary motion, your ability to feel awe at the beauty of Saturn's rings or the ancient impact craters on the Moon, your emotional response to images of Earth taken from space. All of these represent the universe developing eyes to see itself, minds to understand itself, hearts to appreciate its own beauty and complexity. Feel the profound privilege of consciousness as you breathe gently, understanding how your awareness serves not only your individual survival and happiness, but also cosmic evolution's ongoing project of self-discovery and self-appreciation. The orbital mechanics that keep planets in stable paths around stars operate according to the same mathematical principles that govern the formation of galaxies, the behavior of subatomic particles, and the large-scale structure of space-time itself. Picture mathematics as the universal language that connects all scales of existence, from quantum fields to galactic clusters, all expressing variations on fundamental themes of symmetry, conservation, and the optimization of natural processes. The beauty we perceive in planetary motion reflects deeper mathematical harmonies that operate throughout the physical universe. Even our capacity for sleep, for the gentle dissolution of daily consciousness into restorative rest, mirrors cosmic processes of relaxation and renewal that operate on all scales from cellular metabolism to stellar evolution. Feel your own rhythm of waking and sleeping as participation in cosmic cycles of activity and rest, expansion and contraction, complexity and simplification that characterize all natural systems. Your peaceful sleep tonight represents a temporary return to the quantum stillness from which all organized complexity emerges, a brief reunion with the fundamental peace that underlies all cosmic change and growth. The solar system's story continues even as you rest, planets maintaining their ancient orbits, atmospheric circulation following patterns established billions of years ago, geological processes slowly reshaping planetary surfaces according to the patient working of internal and external forces. Breathe gently with this ongoing cosmic activity, understanding how your individual rest participates in the larger rhythms that connect biological cycles to planetary rotation, lunar phases, and seasonal variations in solar heating. Even in sleep, you remain part of the gravitational community that includes every other mass in our solar system. Tomorrow's sunrise will bring light,